In this video, we will be learning about the trick to determine the valency of elements, valencies of first 20 elements. First, we need to understand the duplet stability and octet stability. This can be best understood by studying the electronic configuration of noble gases. Noble gases are the gases of the elements that have the most stable atomic structure. So first, let's look at helium gas. Let's look at its electronic configuration. So in helium gas, K shell, the last shell, has 2 electrons. Note that this gas is stable due to this electronic configuration, right? There are 2 electrons in its last shell. So the tendency of any other atoms of elements to become stable having 2 electrons in its K shell is known as duplet stability. So any elements will become stable by having 2 electrons in its K shell, and this tendency of the element to have 2 electrons in K shell is known as duplet stability. Now let's talk about octet stability. We can clearly see that in the valence shell or the last shell of the remaining noble gases, there are 8 electrons. And note that these gases are all stable gases. So, well, all other elements, the atoms of all other elements, they tend to acquire 8 electrons to have octet stability. So this tendency of atoms of elements to have 8 electrons and become stable is what is octet stability. All right, summarizing, atoms of elements either want to attain stability having 2 electrons in K shell, this is known as duplet stability, or the atoms of elements want to have 8 electrons in their valence shell to have octet stability. All right. So remaining shells, valence shells could be L, M, or N. Okay. Now let's look at hydrogen. Let's determine the valency of this element hydrogen. So hydrogen has only 1 electron in its last shell, which is K shell. Now for this element to become stable, it should have 2 electron in its K shell, right? So how can this become stable? By bringing in one more electron. When we bring in one more electron, total electron 1 plus 1 would be 2. So it would become duplet stable. So because by bringing in one electron, this element can be stable, the valency of hydrogen is 1. All right. Now let's look at helium. Helium already has 2 electron in its valence shell, K shell. So it's duplet stable. No need to bring in electron nor remove electron. So the valency is 0. While I have explained these two elements valency, I will also help you understand the number of electron lost or number of electron gained or number of electrons shared by an element to attain duplet or octet stability is what is valency. Okay, the number of electrons lost, gained, or shared to attain octet or duplet stability is valency. Now let's look at lithium. Lithium has 1 electron in its valence shell, all right, L shell. So in order for this element to become stable, there has to be 8 electrons in total, but there's just one. How can this element have 8 electrons when we if there are 7 more electrons, right? We can bring in 7 more electrons, and then total 1 plus 7 would be 8. Then it would become octet stable. That's one condition. Another condition to become stable is by removing this 1 electron. By removing 1 electron, there would just be 2 electrons in K shell. Then the element would have duplet stability. So another condition is by removing 1 electron. There are two conditions for this element to be stable. either bring in 7 electrons and become octet stable, or remove one electron and become duplet stable. Now, when we compare between these two conditions, it's much easier for the element to bring in one electron than to lose 7 electrons. The energy required to bring in one electron is much lesser than energy required to remove 7 electrons. So because it's easier to remove one electron, the valency of lithium is 1. Next, beryllium. Beryllium has 2 electron in its L shell. For this to become octet stable, there has to be 6 additional electrons, right? You can bring in 6 more electrons to become octet stable, or this these 2 electrons can be removed and then the element could be duplet stable. Let's compare between the two conditions. Bringing in 6 electrons or losing 2 electrons. Much less energy is required to remove 2 electrons. So that's the reason why beryllium's valency is 2. Let's again look at boron. Boron has 3 electrons in its last shell. There's just 3 electrons. For it to become octet stable, there has to be additional 5 electrons. So we can bring in 5 electrons, right? Another condition to become stable is by removing 3 electrons and have duplet stability, removing 3 electrons. When we compare between these two conditions, it's much easier to lose 3 electrons than to bring in 5 electrons. So the valency of boron is 3. Now we've seen the valency determination of up to 5 elements. In the similar manner, by comparing the convenience, by comparing the ease of bringing in electron or losing electron, the valency of the elements can be determined. Let's do it for sixth element, carbon. Carbon has 4 electrons in its valence shell, right? There are just 4. For this element to become octet stable, there has to be another 4 electrons, right? Bringing in 4 electrons. Or these 4 electrons could be removed and then the element would be duplet stable, right? Removing 4 electrons. Now, when we compare between these two conditions, the energy required to bring in 4 electrons and energy required to remove 4 electrons is the same. So the valency of carbon is 4. Let's take the last example, nitrogen. In nitrogen, there are 5 electrons in the last shell, right? For this element to become octet stable, there has to be another 3 electrons, right? 5 plus 3 would be 8. Then it would become octet stable. That's one condition. Another condition is removing all those 5 electrons from the last shell. Then the element would be duplet stable, right? Now, when we compare energies for these two conditions, it's much easier to bring in 3 electrons than to remove 5 electrons, right? Because it's easier to bring in 3 electrons, the valency of nitrogen is 3, right? So the number of electrons that is lost or gained or shared to attain duplet or octet stability is what is valency. Let me repeat that again. The number of electrons lost, gained, or shared by an element to become duplet stable or octet stable is what is valency. Now you can do this, you can try this trick for the remaining part of the elements. I hope this made sense and helped you. Thank you.